Namaste learners, welcome to PlanetSkillzz. I am Pranjal. Now this video is complete roadmap of kickstarting your journey as an embedded engineer from scratch. We will try to share our personal experiences as well, and that will really help you to connect the dots in your own learning journey. We'll try to cover most frequently asked doubts like who should opt embedded systems, is masters necessary to become an embedded engineer, do we need to learn programming, especially C language for embedded systems, what kind of project we should follow, what are the important topics or areas we should cover, and also about various job roles in the field of embedded systems. Consider hitting like button and subscribe to our channel if you find our work valuable. Your support will help us to grow. So let's begin and welcome our guest Yashwant. Yashwant, could you please introduce yourself and share your story of how you started with embedded systems?
Hi Pranjal, welcome everyone to PlanetSkillzz. My name is Yashwant. You can call me by Yash. So I'm pursuing my master's degree in embedded systems at Oakland University in Michigan. I've completed my bachelor's in electronics and communication engineering back in 19, and after that I've done institutional training for advanced embedded degree, embedded systems course, I could say. Yeah. Then after that, I've worked as an embedded software engineer at Scient for a couple of years. Then I chose to come to masters because I wanted to learn more about embedded systems. Uh, that's a short, brief introduction about me. So yeah,
Yeah.
let's. I just want to discuss in today's topic. I want to discuss about how you can get started with embedded systems, even if you're in your early career, if you're in your undergrad, if you're in the transition between the graduation, if you're fresher, transition between one job role to another job role, even if you're interested to, if you don't have any experience in embedded, how can you get experience or how to begin with embedded? How can you use your previous skills in the embedded field, or how can it be useful? We cover all those concepts in this talk today.
Yes, yes, sure. So let's get to the point and start with our discussion. Um, so
Yeah.
let's first try to discuss about who should opt embedded system as a career option and what factors we should look into ourselves. Like, why should we opt for embedded system? Like, what should be our interest to be starting as embedded engineer? What do you think?
Okay, I would like to start from my personal journey on why exactly I chose embedded systems, so that you could also get insight on why uh, how I uh, decided embedded is the right thing for me, because I came from the places you have been, so you could also sync up with that. After my graduation, I saw many people going to IT field, different various fields, going for masters and everything, but no one was looking to stay in the core field, electronics and communication thing. No one was, not many people were willing to stay in that field. When if the EC is vast, so we have VLSI, embedded communications, semiconductor industries, many. It's a vast field, so it's difficult to choose which one. So I personally took 4 months of time to explore these areas and find the right one for me. While exploring the VLSI field or the communication field, I just found that embedded is the right thing for me, because uh, from childhood I like breaking robots and see what's making its arm move in certain way, or what's making it talk, kind of thing. The tiny controller inside, it just grew the curiosity within me. So within those 4 months, I delved more into embedded systems. Although the EC is a vast field, embedded is one more field. It's like an ocean where we have many different kind of job roles, I could say, many kind of from low level device drivers to IoT. It's huge, it's vast, and a single skill can't be expected to be covered in the embedded systems. It's a multidisciplinary field. Uh, it's huge. When I discovered it, I was initially lost on where to get started, but I found that embedded is the right thing for me. My main interest on choosing embedded was the hardware aspect. So apart from the software, I wanted to know when I write a particular line of code, how the binaries are being worked inside the hardware.
So yeah, so to conclude, we can say that if people are interested in understanding hardware, and if they want and they love coding as well, they should opt for embedded system, right? Hardware is must. Like uh, only coding will not help. I think you should have understanding of hardware as well, right? You want to say something about it, like conclude it, like what kind of
Yeah,
people?
Pranjal, whatever,
Yeah, conclude it.
yeah, whatever you said was right. True, yes. I just wanted to add few more points. Like, if you're really doubting to join embedded or not, the first thing you do is some research. Uh, say for a month or two, it's like you're investing month or two to decide your career. If you don't invest this time to research about the topic that you do, you'll be regretting your 15, 20 years of life. To
Yeah.
not do that, just take your time, research about the field that you really want to do, and if embedded is really right for you, then pursue it. The best thing is to search for the evolution of computer, because evolution of computer starts from the making of the device. That's the embedded. Oh, if you want to, I would suggest a movie, The Imitation Game, where they show how the computing actually started, how the idea of computer actually started. During the World War time, they have built this machine. It's a pretty. I don't want to give out the spoilers. It's if you are really interested in how a computer is made or why do we require that, just watch that movie and also read documentaries or watch many documentaries on what exactly computer engineering is, not computer science part, because computer engineering and embedded systems is closely related. Computer engineering depends on the architecture and various aspects of the computer itself, while embedded uses those aspects. So many powerful devices, and you can know how important is embedded when you search for few of the disasters. I could say it's like there is this Theriac medical device where a simple priority inversion, I guess, caused some millions of loss of both life and equipment. It's embedded is a pretty important field. It's not like something it's not like something you pick it up and proceed with that. It directly involves dealing with life when you code. So it's just not like hello world. You're actually interacting with the person when you write your code. So if it's a pretty deep field, if you want to join embedded, just do a thorough research on the history of evolution of computers, the evolution of embedded systems, and then decide on embedded. That would be my suggestion.
Yeah. So in conclusion, we can say that if you are interested in both coding and understanding hardware, you should opt for embedded systems.
Yes.
And yeah, that's it. So the next question is, what do you think is post graduation or any specific training, such as any private training with embedded system institutions after graduation, is necessary to become an embedded engineer, or a graduate person with some free resources can also become a good engineer, embedded engineer? What do you think?
Yeah, that is a great question, and I think that is the main question that's pondering among all the audience. Where to get started in embedded systems is one of the main thing I could say. Uh, so as I said, embedded is a huge field and not a learning a single skill. If you learn C, it's not enough for embedded. You need to know the hardware. If you learn hardware, it's not enough. You need to learn how to interact with the user space and kernel space. You need to also learn about the Linux concepts, about the RTOS concepts. It's huge. To begin with, the embedded system itself is a difficult task, but once you begin it, it's a smooth ride. Okay, so we can actually keeping us if we have time, if you are in an undergraduate, uh, if you're about to complete your undergrad, consider 6 months of time to start to end your graduate, then you can freely download the resources that are available online and start with embedded systems. You don't need much. The basic thing that you can start is with C programming, some Linux concepts. What is RTOS? The RTOS concepts. About a microcontroller architecture would be better. And you need to learn about any particular microcontroller, the architecture, the working. the behind the scenes of that, and how it works, how to interact with that. If you learn these 4 to 5 concepts, that would be good enough to begin with embedded systems. And resources for this are like are spread out throughout the internet. uh, Most people get confused when they search for a particular topic because information on the internet is huge. It's an information dump, and they easily get lost. If they the starting, it's easy to get started, but they don't know when to stop. They begin with C, but they don't know where to end or when to end. It's This field requires everything to do in parallel. You can't just begin with C and keep on doing everything in C. Once you're good with the concepts of, let's say, until structures and unions, then you can parallelly uh, opt another topic. Consider in Linux, you can just take a system call, understand what's working behind that. You can implement some projects on that. So this in this way, you're learning 2 skills at one time, 2 or more skills. Like when we say Linux, it's a huge field by itself. So uh, getting started this way requires 4 to 5 to 6 months of time, because the first thing we need to do is prepare a map of our own and follow it. The important thing is consistency. We prepare a map, we collect all the resources, we bookmark them, we save them, we download them. But we hesitate to open them when we want to study. That's the thing happens with most of the people.
Yeah, so I also believe that new learner, like if we want to start learning in any new area, right? So because we are not aware about that area, so obviously our brain need some load to accept those new things, right? So it's very easy to get
True.
distracted at that initial point of time. So I think we should have some right direction to become good at anything when we are very beginner to that new thing, right? So you should opt for any training institute or master's program. I believe that. And also it really depends upon a particular individual and what kind of circumstances that individual is having. So let's say you have already done your graduation from good NIT, and now you know good programming and you are a very good student. So understanding basic embedded system concepts will take you 2 or 3 months. So in that case, you can refer to any free resources available on internet, right? But let's say you are from very normal college, from tier 3 college, and now you have a good chance of getting into good college via gate examination to do embedded system, right? Master's program. So that is very win-win situation for you, right? So it depends upon circumstances. You can definitely opt for this kind of program.
Very true, very true. Very true. I also wanted to add, just before you start to pursue your master's program, or just before you opt a institute for training, have a talk with few of the people who are already working in that field. In that way, you'll be more confident that this is the right field for you. Or about in the researching part, you know the background work or the theoretical practical part that's been implemented, but it would be different when you talk with the person that who is already working in that field. You'll get more insights in that, and you'll know when to pursue masters, or is coaching institute necessary, or you can have that person as a mentor by himself. He can guide you, like you have collected your resources, but it's scattered everywhere. He can guide you to having a good mentor is a good thing. Like he can guide you to segregate all those resources together, to categorize them, and it give them back to you so that you can follow that path. Having getting in contact with some person who has a good amount of years of experience in embedded, or who already got started into embedded, would be a good approach to get started with embedded. That's one of the thing that I want to say.
Yeah. So we were discussing about there are lots of good creators. So people who are starting as an embedded engineer, they can take help from this kind of community from LinkedIn or any other social media platform. They can connect to us as well. We are also available. And yeah, so community and mentor plays a good role while when we are starting as an embedded engineer.
Very true, very true. I agree with that. Yeah.
So you had any mentor when you were starting, or how?
I did. I actually did. So it was during my career transition after my experience at Science as an embedded engineer. I wanted to move to a different company, or I was pursuing two options at once, either masters or different company. So the concepts that I learned at the company I could say, weren't exactly the ones that I was seeking for the domain I was working for. I was more interested into the low level kind of thing, memory management, how that's the scheduling, how things behind happen when we write the program. So I wanted to learn more about that. And so when I was applying for the company for that role, I thought like after giving few interviews, I thought like I need to skill up a bit more. I need a proper guidance in this particular area. Now I know I'm from ECE to embedded to a specific field in embedded. So domain was fixed. Now the field is has yet to be fixed. For domain, I've used all the internet available free resources and contacted people. I was somehow into embedded. Now I need to choose a particular field that I would work on that would interest me. So that's when I met Balamarthi Vamshi through LinkedIn. He's a career mentor. He's a early career coach. I could say a sort of revelation for why I wanted to pursue embedded or why I wanted to pursue that field in embedded. I got a good clarity when under his mentorship. It's like I have know the clear difference between job, career, and our learning. Our job is not a career. It's not a life. It can change anytime. Our career is one thing that's guided me on as I told, choosing a field is important in embedded. I've asked him, I've had many discussions with him under his mentorship. He provided with me deep insight on why exactly I want to choose that field. What is the advantage? What is my end thing? Is it the money? Is it the fame? Is it a device? Or is it for future generations? Whole roller coaster of thoughts, deep thoughts, or deep thinking has been involved for weeks to particularly decide on why embed and why at that particular field. So what my aim was. And once I fixed that, he provided me with some technical resources. He provided with me from projects and also the LinkedIn. He introduced me to the LinkedIn community. And since then on, we both are, on fire. Like we want people in embedded, and now that we know we are embedded, we want them.
He talks about Balamurthy
Very
sir
true.
talks about the early embedded career, how we can start. Like I will add his profile
Yes.
all in the description box. Like if anyone wants to join him or if anyone wants to learn from him, for convenience, I will add the link for his profile in the description. So yeah, that's it for this question. Let's move on to the next one. So now let's consider that a person decided to opt for embedded engineering. So what do you think? How he should start learning as a beginner? What kind of topics or what kind of areas? Let's say C programming, electronics, CPU architecture, DSA, algorithms, or operating system. So how should he proceed learning these topics? And how should he start as a beginner? What do you think?
Yes. So that is a nice question. To get started with embedded, now you are fixed that you are doing embedded. Now you need to get started with that. No, it's not just theoretical learning. It's going to involve you're gonna get ready for a good ride. It's gonna be a tough ride, but a good one. But things will smoothen on later in the journey. Initially, it might be the information is overloaded, but they are the important concepts that you'll be usually using on back problem when you do the embedded stuff that they're actually working on. To get started, the important thing is C. It's mandatory. If you don't know that, you need to learn that. Somehow you need to learn it because C is the closest to the hardware. Assembly being the one, next comes the C. It's understandable both by the user and the device. Being an embedded engineer, your main interest should be on how to handle the hardware. Hardware is your toy. Hardware is your friend. You need or something that you can modify. You need to know how to interact with that. You need to know how to shape that. It's like a pottery wheel. You are shaping that device to work into a particular uh, for any particular work. So uh, to do the hand movement, to do the shaping, you need the C. It's now you're interacting with the hardware and making your own, like your idea is being thrown into that device, and that device is visualizing your idea in real time. So C is a must if you want to learn embedded. And the next important concept is a
So
microcontroller architecture. Let
one
it be
second.
805.
1 second. I want to stop you here, and I want to discuss one more thing about C. Like, what do you think? Like,
Yes, yes.
C is the must, or any other language also can help? Like, if someone don't want to learn C language, let's say, like many people will ask this question, right? So just throw some light, like why C is important for embedded system development. So just share some insight on that. That is very important, I think.
Yeah, yeah. So when the why C question is an important one. C is a bit difficult. I know it'll be difficult in learning at the starting stage. Why it's important? It's closer to hardware. When I throw it verbally, it's closer to hardware. You might understand somewhat like if I give variable int a, it'll just be in the hardware that way. Or if you, it's not that just giving variables. You will be interacting with the registers. So the importance of C or why C is you can only realize that when you look at the files that are produced in the compilation stages when you write the C file. Those files are very much closer to the hardware itself. You can modify those files. If I tell you to write a program in assembly, it's gonna take time. Hello world, a basic hello world program is gonna be difficult, and when it comes to assembly, we need to know a specific processor it's working on. Let it be RISC-V processor, sorry, RISC-V instruction set, let it be ARM instruction set. You need to know the specifics and the hardware to write a particular, like a simple command as a simple program as hello world. It's going to be, or blinking LED. It's going to be difficult when you get started with this assembly part. So assembly part you can take later on. If you use C++, I don't think that will be interacting directly on hardware. To interact directly with the hardware part, when I say hardware, if you want to use the register inside the CPU, C is the only way that C has the keywords, right? The registers variable that will just handle those areas that not other programming languages can access. When you go to Python, it's on high level. You can use it for scripting, but not for the interacting with the hardware part. C is the closest and the only programming language that I could think of to get started in embedded systems that's closer to assembly. So it's easily two stages. One is the preprocessor, next would be the assembler. Sorry,
Yeah,
translator, but it converts C to assembly. So C is a must, and that's you need. It's easily
yeah,
modifiable.
yeah. And also in embedded system, like we have resource constraints, right? So memory will be limited.
Yes,
So
yes,
the C executable will be very small usually, like as compared to
very
higher
true.
level languages. Let's say we have Python, Java. They will have interpreter, Java virtual machine, right? They will need that thing also, and their executable will be of larger size as compared to C. Apart from that, pointers, like we don't
Pointers is the main thing. Yeah,
pointers is the main thing. We don't have something like pointers in Python or Java. So that is very important for memory manipulation in embedded system. So
very true.
yeah,
Very
so we
true.
can say like if you want to achieve real time embedded system, like so C is very important, right?
Yeah,
So yeah, so yeah,
yeah, very true. I'd like to give you an example. Like if you give that output C output file, you need to also consider the execution time. When we say this real time, it's gonna take into a different dimension altogether because like real time is something like if you're in the car, the airbags need to be deployed as soon as you hit it, not after 2 seconds, not after 1 second. You'll be dead by then.
we
It's need to
discussed
be
this
like as soon as
earlier
you
as
hit it,
well.
yeah. It needs to deploy as soon as possible. So C's executable file makes that possible.
Yes.
Not any other. It's huge and it takes so much time to execute.
So
See, when it's
this
real
is
time,
very,
yeah,
yeah. So like we have already discussed, like these are very small things. Like no one will give damn to these
yeah,
kind of things, but how they are really important in bigger applications. that we need to think of.
Mm-hmm.
Yeah.
Very true. Very true. Yeah, very true.
Yeah.
The
So
impact of writing
yeah,
programming.
that pretty much concludes that we need to learn C language. We can pursue other
Yes.
languages also. I think now many developers started pursuing Python also for embedded applications, and yeah, many people have started using Python also. But C is must for understanding the basic real-time embedded systems.
Very true. I just want to give just a small hint to users. The best application of C you can see is Linux. Just open the open source code and you can see everything is written in C.
Yeah.
Everything, literally, even they include assembly here and there, but everything is written in C. It's highly portable. That's the main aspect. It's highly portable, and you don't need a separate IDE or anything. You can just type it, and you just need a compiler to run it. You
Yeah.
can individually build all these aspects, write your program, and run it. But for other applications, for other programming languages, I don't think it's possible to do these things together.
Yes.
Yeah, that's what I wanted to add.
Yeah. So yeah, that's pretty much sums up that why C is important. One more thing, how much C programming we should learn? We should know DSA concepts thoroughly, or what kind of level we should achieve in C programming as an embedded engineer. So explain on that.
Okay, if you're very new to C, just begin with the hello world programming. Just understand the basic syntax of it, how libraries are included, various library types. Well, I mean, Angular braces, double quotes, the main difference between those, and that's gonna give you a headache if you don't understand them properly because you declare your own library, .h for header file, and you use Angular braces. That's gonna cause some trouble. So you need a thorough understanding of the various aspects of the syntax itself. Once you're good with the basic syntax, you can just start with addition programming, a simple calculator. Then you can proceed ahead with arrays. Now, the next concept that's going to cause trouble for many people is the pointers. Pointers is the most important topic in the embedded programming part. If you don't understand that, you can't exactly figure out working beyond in the hardware or why it's working the way it is. You might assume the compiler is doing magic and you might just leave it. Pointers getting I would say work do many programs as many programs as possible on pointers because for at least 2 to 3 months only then you'll be getting a good amount of knowledge on how pointer is. You can say there are different errors theoretically. When we study in a bachelor's, they say we got dangling pointer, we got wild pointer. We just say theoretically, or we can just give sample example, written example, and we don't know what's happening. If you really want to know the difference between dangling pointing, wild pointers, and all the kind of pointers, why we use void pointers when it's necessary, you need to program them. You need to compile, debug them. Debugging is one of another important aspect that an embedded engineer needs. Once you're done with the pointers concepts, you can go with this, what do we say, structures and unions. Because arrays uses a similar data type. In the structures, you use different data types. The best understanding when you uh, what is go through this journey, open source code, read that. Code reading is a must. Just take any open source code. Linux, if you take an example of simple printf code, you can find the definition of that, not declaration, definition of that in one of the open source codes. Just see how it's written, how it's structured, and why to use, where to use. Once you're good with structures and unions concepts, I think then you're okay to get to some advanced concepts in C programming. And when we talk about uh, the DSA part, learning about the sorting techniques, searching techniques, if we generally try to learn like, okay, I'm done with structures, now I need to learn bubble sort. I need to learn about binary search. These don't work that way because when you do these DSA concepts, it's not going to exactly show you or give you the feel of what exactly your motive is behind writing those programs. When you take a simple open source code, if you browse through that, you can see those algorithms, sorting, searching algorithms being used in a wide scale. We use in the string library string.h, we find that we have string copy. When you look at the code of string copy or Oh, just string copy. There is this function called stri. Uh, I I forgot that function. It just searches for a subset, so you can see which it just gives you instantly. But that's when you write that function name on in the user level. But behind the scenes, they have implemented few algorithms where they make the search faster. So when you look at the back end of working of the code, then you can realize the importance of these algorithms, searching and sorting algorithms. We have quick sort function within the C itself. You when you don't need to you just need to know the parameters to pass, but the working is handled by it's already written. So if you want to learn an open source code, go read through that thoroughly. There are many open source codes available. Read through that thoroughly and understand how it's written. Only then you'll know importance, or then you'll get the motive of learning a particular algorithm or particular DSA topic. If you want to learn bubble sort, you can't just blindly write a simple array program and give random numbers and give a bubble sort to that. That's not that's not giving you a proper application of that. Instead, go to the online sources. You can see where bubble sorts is actually showing effect in real life. So linking when you write C program, you also need to, since you're doing it in for embedded, however generic it may be, just make link it with the real time effect of that.
Okay, so you mean to say,
That would be one of the
so like you mean
project
to
based
say,
approach. Yeah.
yeah, so you mean to say like if we are using bubble sort, try to understand at which application it should be most optimized, right?
Yes. 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 Where it can be used or which scenario can be this be
It's
taken up. If
okay.
we write bubble sort, yeah.
It's not like in every sorting. If you know bubble sort, let's use bubble sort.
Nah.
You should have
Yeah. Yeah.
understanding of each and every sorting mechanism, and you should know the application and how these sorting techniques will be more like we can use in more optimized way. That you should know, right? So yeah,
Very true.
in the conclusion, we can say like you should first start with basic C programming. Just master basic C programming. Pointers, structures, and function pointers or functions are must. Master them. Then start with basic DSA. Try to cover linked list.
Linked list is must.
Yeah, linked list
Yes.
stack and
Queues.
queue can be covered, right? There are some
Yes.
kind of
Yes.
application of queues also. Like stack have lots of application in embedded system while using function calling and all that stuff. Linked list also have lots of application when we use buffer for memory. There we have application of linked list. So yeah, these two DSA and array is so must, and I think every new coder will learn array naturally, and yeah, they will be good at it. So yeah, I think that much C programming is enough, I think. So I think learning simple concepts and mastering them, understanding them, how they are working on hardware, how they are impacting hardware, that is important. Apart from learning very good coding skills or something like that, right? So yeah, so
Yes. Yeah.
I think for C we can conclude here. Let's try to move forward and quickly try to understand what other topics are important for embedded engineers. But programming is must. Half of the work is done over here. Now the later half of the work.
Okay. Yeah. So now you are good with C. Now you're able to program. You're able to create a menu thing. Now you're able to write a simple undo redo program. Now the challenge is to implement that on a hardware. Undo redo or how to blink an LED. You just now need the experience or the knowledge of a particular hardware device. The basic, the simplest thing that you could get started is with the Arduino. It has a huge community. The thing to note when you are starting with Arduino is when to stop it. Because many people get started with Arduino and just continue that throughout their better career for like 1 2 years and think Arduino is the only thing. That's not it. There are many things above Arduino, but Arduino is the simplest and the easy thing to begin with. When we
Every
say
library is
yeah,
available, and that
yeah,
somehow hides the CPU architecture CPU architecture understanding. Like people who are working on Arduino, they don't know anything about CPU architecture. They don't care. They just use library and they just try to you make as many applications as possible.
Yeah, true. Uh, it's easy to begin with Arduino, and if anyone is starting to get it embedded, I would suggest get started with Arduino, but don't get stuck to it. Do some projects, do some basic. Begin with LED, blinking LED, then go ahead and do some project like gesture control robot from Arduino, and then you can skip to different microcontrollers. But don't stay on with use as Pranil said. It does not. It hides the CPU architecture. It hides how it's working behind the screens. But as an embedded engineer, you need to know how it works, because when you write the code, you are making sure that the entire pipeline and the code within the hardware is optimized and it's working well. So once, if you just write in the Arduino IDE, if you run that and compile it, you can see the output, but you don't know what's happening behind that. But you need to know how it works behind the scenes. So don't get stuck with Arduino. To begin, that's okay. Arduino is okay. And also the next concept is when we move from Arduino to different microcontroller. So in Arduino, you just write analog.read, digital.read. You have the functions, to enable them and just write some value in that. Consider you moving to a TIVA board, Texas Instrument TIVA C board. There, you just you put a pin on the LED and you put a pin to the ground. Try to run a blink LED program. It does not work. That that's where you need the knowledge of data sheet, how to read the data sheets, because when we all the pins, not all the pins are GPIO pins, so you need to know understand which pins are GPIO pins, how to enable them, and internally when we say this architecture, it's not just how the pin is connected, but no externally, but inside. So if you consider the TIVA board, it's got like 7 different configurations on how one pin can be set, and that can be only done by writing software. So when you do that, you need to consider you have a 8-bit register. Each of these bits indicate a different configuration. Each of this consider this 7 bits, excluding last, will act as a different like one could act one if you set this bit particular register as 0, and if you set this as 1, it would act like a digital. If you set this as 0, it would mux it. So here you understand on the importance of embedded. Like you are actually interacting with the hardware, you're setting it. The manufacturer prepared and everything, he kept it right there. But now you are trying to create a good recipe out of it. You trying to get a good dish out of it. You got a recipe, you got everything. The data sheet is your recipe sheet. You just need to know when to add salt, how much salt to add, or what ingredients to add to get a good dish. That's where the skill of reading the data set and understanding the CPU architecture comes into place. So when you have C, you got microcontroller CPU architecture part covered. Now we also need to understand uh, some basic Linux, or how to run on a Linux system, because Linux is huge portable. It's available everywhere. It's free of source on Windows itself. If you don't have any Linux, but not worry, we can just download the Windows subsystem for Linux and run Linux on Windows. Try to interact. Linux gives you flexibility on exact. I could directly link Linux with embedded. I mean, that's so close. We can literally see how each of our instruction is getting translated into assembly and how it's getting dumped into the hardware. That's so beautiful. I mean, Linux is a important concept to learn on how to handle files in that, how to get data, how to send data from one device. Consider, set up from one device to another. The next important concept is the protocols. I2C, SPI, CAN, UART. These are the basic protocols that you need to have when you learn embedded systems. Because having microcontroller, you have 30 to 40 pins. You don't know what to use with them, but I mean, it's not LED or running a motor. You need to interact with all these multiple sensors all together at once. That's when these protocols come into place. And I2C, I think you can connect 128 devices. So you can take like 5 to 6 motors or 5 to 6 LEDs, different in outputs. On one side, 5 to 6 buttons switches on one side. You can just connect in the I2C protocol. You can make sure that whenever you press this, only those particular things light up or run. These protocols are pretty important. When I say LEDs and motors, these are basic stuff, but on higher level, there is a pretty important need for these concepts. Without protocols, you can't do anything in embedded. Without because embedded is all about connecting with the sensors, connecting with the actuators, using them as inputs and outputs, modifying our particular device based on that. So you need to understand how the sensors work. That's one more skill that many needs. The basic electronics. When I say sensors, it comes back to basic electronics. Understand where what's ground, where you can get the which pin you can get the data from, which pin you need to give the VCC, which pin access what, uh, and uh, and also some RTOS concepts. If you are interested in the well, I don't think I can say interested, but RTOS is some needed concepts because it's writing a real time programming. So RTOS gives you an idea on the process management, thread management, semaphore management, mute happens behind the CPU. In Linux, when you write a simple C program and compile it using GCC, it just gets compiled. But when you're behind the scenes, you need to know, but you would want to know which
Okay.
scheduling is being done, earliest deadline first or round robin. How many threads are created when we run a process? Is it a single thread or it's being how many cores it's being executed on? You got 10 core laptop, but you're using a single core to run on it. How can you parallelize your program? These things come into place when you are planning to learn about RTOS. And these are pretty important things. Uh, that's one more thing. RTOS. I think these are a good amount of basics to begin with in embedded. Although it's huge to begin with, but these are the basics that are required for that.
Okay. Yeah, that's it. I think we have covered all the basic things which are required to start as an embedded engineer. Uh,
Mm-hmm.
if audience have any questions or they have any doubts, they can write it in the comment section. Or we have our LinkedIn profiles. I'll add them. I'll add link to the LinkedIn profiles in the description as well. So they can reach out to you or me on the LinkedIn and they can ask us like whatever doubts they have. Like both Yash and me are happy to help you guys. And yeah, thank you, Yash, for participating in the discussion. I think many more to come, and it was very nice talking to you. And yeah, let's try to have more discussion and let's try to learn from each other as much as possible. So yeah, thank you once again.
Thank you so much, Pranjal, for inviting. And it's been a great interactive session with you and with the audience. It's going to be, I think the comment section is going to be a blast in some time as soon as this is released. Uh, and also, guys, you can contact, as Pranjal said, either of us in through any medium. We are always available on LinkedIn. So do like the videos, share it among your friends who are willing to join the embedded field. It's going to be an interesting time when
Yeah.
you learn this embedded. Yeah.
Yes.
Share your thoughts in the comments and stay tuned for more such informative videos.